Yeah. So very good afternoon once again to all of you. So we are discussing the redox reactions, right? So can you guys remember the topic that we have discussed in the last class? We had our last class on Wednesday, right? Last Wednesday. So in that we have discussed the types of redox reactions. Okay. So there were 4 types of redox reactions. One is combination reaction and the other one is decomposition reaction. The third is displacement reaction and the fourth is disproportionation reaction. Okay. Combination, decomposition, displacement and disproportionation. So out of these 4, we have completed the first 3. Okay, combination, decomposition, and displacement we have completed. If one compound is breaking down, if 2 compounds are combining together to form a new compound, then it is called as combination. If one compound is breaking down into 2 or more than 2, then it is a decomposition. And displacement means there were 2 types, metal displacement and non-metal displacement, right? So A plus BC will give AC plus B. So this will fall under displacement category. All right. So today we are getting into the 4th type of reaction, which is called as disproportionation reaction. So what is called as disproportionation and what will happen in this reaction? So usually an element is simultaneously oxidized and reduced. One element will undergo oxidation as well as reduction. Okay, in the simultaneous manner. Got it? So we may have more than one reactant, right? So one of the reacting elements should exist in at least 3 oxidation state in this reaction. One of the elements should exist in at least 3 oxidation state. So let me give you one example. Okay, so let me take H2O2. H2O2 is giving H2O plus O2. So here all the oxidation numbers of all the elements are given. So in case of H2O2, oxidation state of hydrogen is +1 and for oxygen it is -1. So you all know why oxygen is taking -1 charge here, right? So in case of peroxide, the oxidation state of oxygen is -1. Okay, so that's why. And in case of water, hydrogen takes +1 and oxygen takes -2. And the elemental oxygen will have 0 oxidation state. Okay. So these are the oxidation numbers given to all the elements in the compounds. Now, if you look into the compounds properly, oxygen is moving from -1 to -2 in one product. If it is going from -1 to -2, it is called as reduction, right? And the oxygen is moving from -1 to 0 in another product. -1 to 0. So it is moving towards positive direction. So it is called as oxidation. So one element is getting reduced as well as it is getting oxidized. Okay, totally it is existing in 3 different oxidation state in this reaction. Okay, one of the reacting element is existing in 3 oxidation state. So this type of reactions are called as disproportionation reaction. Okay, so in the first case, O2 is getting, -1 of O2 is getting converted to -2. And in the other case, it is getting converted to 0. Oxidation and reduction takes place simultaneously. Clear? One element should have 3 oxidation state. One should get oxidized and the another one should get reduced. Okay, the very important thing that you have to note down is the oxygen cannot move from -1 to -1 to -2 and -1 to -3. This is not possible. Because in both the cases, if you see -1 to -2 is also called as reduction. -1 to -3 is also called as reduction. Okay. So in this, it is having 3 different oxidation state. But 2 products that are being formed are the reduced product. If it is so, then this kind of reaction is called as, not called as disproportionation. Okay. One should get oxidized and the other one should get reduced, and we should have 3 different oxidation number for that element. Are you getting my point? Is it clear? Is it clear to all of you? Students, can you able to understand? One should get oxidized, the other one should get reduced. So here it is getting reduced and here it is getting oxidized. Those reactions are called as disproportionation. Okay. Both should not get oxidized or both should not get reduced. You have to keep this in mind, okay? Because they will give such a kind of reaction in the examination to confuse us. So please be very careful. Okay. Great. So now let's go for the next point about disproportionation. Okay. Phosphorus, sulfur, and chlorine undergo disproportionation in alkaline medium. So we are going to see one example in which the phosphorus is going to react. Okay. Alkaline medium means basic medium. Usually basic medium will have OH minus ion, right? So phosphorus is going to react with OH minus to give the product. So let me show you the reaction. So P4 with the 3 OH minus is giving, and with the 3 H2O is giving PH3 H2PO2 minus. So you can see the oxidation number for all the elements and you know how to calculate, right? Go for the oxidation state of phosphorus. So in one of the compound, phosphorus is moving from 0 to -3. It is moving from 0 to -3. So what it is? 0 to -3 means reduction. And here 0 to +1. +1 means it is oxidation. So phosphorus is getting reduced and also it is getting oxidized. So it is an example for disproportionation reaction. Okay. Understood, students? Any doubt? Do you guys have any doubt here? Okay, fine. So now let's go for one more example in which the sulfur takes place in the reaction. See this. S8 with OH minus gives S2 minus, S2O3 2 minus and H2. This is another reaction. You don't have to worry about the reaction, okay? Reaction will be given to you in the question. You just have to find out which among the following is the disproportionation reaction. For that, you need to know how to calculate the oxidation number for each element. That's all. Okay. No other thing you're going to do. No other concepts are being used. You need to find out the oxidation number. So that is what you have to do. Then you have to check. So here you see sulfur is moving from 0 to -2 in one compound and 0 to +2 in another compound. Okay. 0 to -2. So this is reduction and 0 to +2 is called as oxidation. So one element is having 3 different oxidation state. One among it is reduced and the other one is getting oxidized. Clear? This is the next example. Now, third example. Third example is with chlorine. So chlorine with the OH minus will give ClO minus, Cl minus and H2O. And here if you look into the oxidation number of chlorine, it is going from 0 to in one compound, 0 to +1 oxidation and 0 to -1 which is called as reduction. Okay. Clear? ClO minus. ClO minus is one compound which is used to, which gets oxidized. It oxidizes color bearing stains of the substance to colorless forms. I mean, it is used to remove the stains. Dirts. Stains means dirts. It is used to remove the dirts. Okay, it is getting oxidized. So ClO minus is one of the very important compound which removes the color bearing stains to colorless stain. Okay, which is falling under the category of disproportionation reaction. So can you all able to understand? Reactions will be given to you. You don't have to worry. Find out the oxidation state and find out the product. Okay. Shall I go for the next slide? All the reactions which you can see on the slide are very important. Okay, very easy question, but very important. Shall I go for the next? Do you guys have any doubt here? Shall I go for the next, students? Okay. Thank you, Nandini. So let's go ahead with the exceptional cases of disproportionation reaction. So if you take fluorine reacts with alkali. Alkali means OH minus. Okay, it reacts with alkaline solution. And it will give F minus, OF2 and H2O. This is one of the reaction. Okay. But here you see fluorine is going from 0 to -1 in one reaction. Means it is reduction. And 0 to -1 in another compound, which is also called as reduction. Do you think that this is an example for disproportionation reaction? Can you write this reaction as an example for disproportionation? What is your answer? Yes or no? Yes or no, students? Is this reaction an example for disproportionation? Say yes or no. Don't get scared. I told you the criteria, right? I already given the criteria. Then why you guys are getting stuck? Yeah, it is not an example for disproportionation. Very good. Why? In both the cases, the fluorine is getting reduced. Fluorine cannot have the positive oxidation number, right? Fluorine cannot have positive oxidation number. The reason is, it is the most electronegative element. It is the most electronegative element and it cannot exhibit positive oxidation state. When an element will get the positive oxidation state? Only if an element loses its electron, it will get the positive oxidation state, right? So I have hydrogen in 0 state. And if this hydrogen gets converted to 2H plus, it is moving to 0 to +1. So only if it loses 2 electrons, 0 state will be converted to H plus state, +1 state. But since fluorine is a most electronegative element, it will not lose its electron. It will always gain the electron from the species to which it is getting reacted. Okay, so it will never have positive oxidation number. So fluorine containing compounds will fall under the exceptional cases of this reaction. Okay, so fluorine does not exhibit the disproportionation tendency. Okay, so this is a very important point you have to keep in mind. All right. Shall we go for one question? Shall we solve one question from the disproportionation reaction topic? So there is no doubt in disproportionation, right? Let me go ahead with one question. Are you all ready? Are you all ready? Only if you reply, I will move on. Okay. Thank you, Sutra. So here is the question. Identify the disproportionation reaction. Identify, Nandini, go ahead. Identify the disproportionation reaction. So we have 4 options. You guys need to find out the disproportionation reaction. Find out the answer. Which option is correct? Which is correct? Option A or B or C or D? Let me see who is finding the answer. Correct answer first. Guys, find out fast. It is very easy, no? Find out fast. You just need to spend your time in finding out the oxidation number. Okay, rest other things are very easy only. None of you have arrived at the correct answer yet? Oh my God. I am waiting for your answer. Waiting for your reply. I want the answer at least from one person. What about the first reaction? Option C. Subhra is getting option C. Okay, let's check. Let's start from the first. Let me start with option A. So in option A, all the elements are taking this particular oxidation state. Okay. So here if you see, oxygen is moving from 0 to -2 in both the cases. So it is not an example for disproportionation. Then if you go for the second example, here chlorine is moving from 0 to -1 in both the products. So it is also not the example. If you look into the option C, here we have fluorine 0 to -1, going from 0 to -1, and oxygen going from -2 to -2, and hydrogen from +1 to +1. So the oxidation state remains same for oxygen and hydrogen, but for fluorine, the fluorine is undergoing only the reduction, not the oxidation. So it is also not the answer. The fluorine containing compounds will not fall under this category at all. Then why Subhra have given me the option C? You have said option C only, right? So option C is incorrect. Option C is incorrect. Just now I said no, fluorine containing compounds will not fall under this category. So the correct answer is option D. So see here, look into the oxidation state of nitrogen. Nitrogen is moving from +4 to +3 in one compound and +4 to +5 in one compound. So we have the line 0, 1, 2, 3, 4 and 5, right? So in one case, it is moving from +4 to +3, moving towards left. So it is reduction. +4 to +3 is called as reduction. And in the other case, it is moving from +4 to +5, moving towards right side. So it is oxidation. So this is oxidation. So one element is getting reduced and as well as it is getting oxidized, right? So option D is the correct answer for this question. Can you all able to understand? Can you all able to understand? If you are facing any struggle in finding out the oxidation number of nitrogen in NO2 minus and NO3 minus, I will teach you. So NO2 minus is there. So we are going to find out the oxidation state of nitrogen. So take it as X. And each oxygen will carry -2 charge. So 2 into -2 is -4. And also it has gained 1 electron. So you can put +1 equal to 0. It has gained, no? So put +1 equal to 0. So X is equal to +4 minus 1, which is equal to +3. So this is how you have to calculate for NO3 minus also. So what will come for NO3 minus? Take nitrogen as X. 3 into -2 is -6. And it has gained 1 electron. So +1 equal to 0. So 6 minus 1 is equal to 5. So can you able to understand now? Students, any doubt? Any difficulty? Can you all able to understand how to solve this type of question? Do you have anything to ask or any doubt? Yes or no? Okay, it is clear. Great. So here we are concluding the types of redox reactions topic. Let me summarize again. So combustion reactions, which make use of elemental dioxygen as well as other reactions involving elements other than dioxygen, are redox reaction. Decomposition reaction leads to breakdown of a compound into two or more components. Displacement reaction, if you see one element in a compound is replaced by another element. Okay. In disproportionation, an element in one oxidation state is simultaneously oxidized and reduced. Okay. So this is the summary of the types of redox reactions. Okay. So now let's go for the next topic. The next topic is balancing of redox reaction. So under this, we are going to learn the methods to be used to balance the redox reaction. Okay. So there are two methods. One is oxidation number method and the other one is half reaction method. Using these two methods only, we are going to balance the redox reaction. Okay. Shall we start with the oxidation number method? Ready? So what is the difference between balancing a redox reaction and balancing other normal reactions? Any idea? Do you have any idea? What is the difference between balancing a redox reaction and balancing the other reactions, other normal reactions? Suppose if I have H2 plus O2 is giving H2O, right? This is a general reaction which we all know. And if I want to balance, I have to put 2 here, right? And 2 here. So now the reaction is balanced. And here to balance a redox reaction, we are going to use these two methods. So means it is different. Balancing a redox reaction is different from balancing a general reaction, normal reactions. Okay. The difference is, in case of the normal reactions, we balance only the atoms. We balance only the atoms. So we will check the number of atoms. Okay, here 4 hydrogens and here also we have 4 hydrogen. And here we have 2 oxygen. Here also we are having 2 oxygen. So here we count the number of atoms. We will look into the total number of atoms present in the reactant side and the product side. Okay. But the redox balancing involves balancing of atoms, balancing of ions, and balancing of charges. Okay. Redox balancing involves balancing of atoms, balancing of ions, and balancing of charges. Okay. So all these three things has to be balanced. So that's why we use these two types of methods to balance a redox reaction. Okay. Clear for all of you? Shall we start with the oxidation number method? Shall we start with the oxidation number method now? Yes. Let's study how we are going to balance the atom, ions and charges. Okay. So let me start with the oxidation number method. Oxidation number method. So let me take one example of an unbalanced equation in acidic medium. Unbalanced equation in acidic medium. Okay. So this is the equation. So this is the equation in acidic medium and this reaction is unbalanced. We have to balance this redox reaction. Okay. The very first step that you have to follow to balance this reaction is, in the step 1, assign the oxidation number to all the elements in the reaction. In oxidation number method, what you have to do as a first step, assign oxidation number to all the elements in the reaction. Okay. So here is the oxidation number. So how to find out this? Let me show you for Cr2O7. So Cr2O7 2 minus. We are going to find out the oxidation state of chromium. So we have 2 chromium, right? So it is 2x. So there are 7 oxygen. So 7 into minus 2 is minus 14. And it has gained 2 electron. So plus 2, which is equal to 0. So 2x is equal to 14 minus 2. So it will be 12. And x is equal to 12 by 2, which is equal to 6. Okay. So this is how we calculate the oxidation number for each element in the compound. Clear? So assign oxidation number to all the elements in the reaction. So we have chromium, we have oxygen, we have sulfur. Okay. We have only these 3 elements in this reaction, and I have assigned the oxidation number to all the elements. So chromium is moving from plus 6 to plus 3. Plus 6 to plus 3. Okay. Plus 6 to plus 3 means it has gained 3 electrons. So it is an oxidant. It is an oxidant. If it is gaining 3 electrons, it is called as oxidizing agent, right? So it is an oxidant. Oxidant or oxidizing agents. Both are correct. If you look into the oxidation state of sulfur, it is moving from plus 4 to plus 6. So it is losing 2 electrons and it is moving from plus 4 to plus 6. So it is the reducing agent. It is losing its electron. Okay, loss of electron means it is called as a reducing agent. Okay, so SO3 2 minus is a reducing agent or reductant. Okay, so what we have done? We have assigned the oxidation number. And we are finding out the oxidizing agent and the reducing agent. Okay, this is step number 1. And in step number 2, you have to balance all atoms undergoing the change in oxidation number. So what are the atoms undergoing change in the oxidation number? Chromium and sulfur, right? Now we have to balance those atoms. Listen here. So we have Cr2O7, chromium and sulfur. Chromium and sulfur. These 2 are the elements which is undergoing change in oxidation number. In the reactant side, I have 2 chromium, but in the product side, I have only 1 chromium. So what I have to do, I have to multiply the product chromium by the number 2. Okay, so that I will get 2 chromium in the product side also. And if you look for the sulfur, so we have only 1 sulfur in left hand side and 1 sulfur in the right hand side. So sulfur is already balanced. Sulfur is already balanced. So I am balancing only the atoms of chromium. Okay. So just by multiplying it with the number 2. Clear for all of you? Shall I go for the third step? So in the first step, what you have to do? Write the oxidation number for all the elements. Then balance all the atoms which is undergoing oxidation number, change in oxidation number. Okay. Then in the third step, find the total change in oxidation number for entire molecule. Find the total change in oxidation number for entire molecule. So in case of Cr2O7 2 minus, the total change in oxidation number for the entire molecule is minus 6. Okay, it is minus 6. And for SO3 2 minus, it is plus 2. Okay, it is plus 2. We have 1 sulfur in both the case, so it is plus 2. But here we have 2 chromium, right? 2 chromium. For 1 chromium only, it is minus 3. 2 chromium means minus 3 into 2. So it will be minus 6. This is the total change in oxidation number for the molecule. So the minus 6 and plus 2, they are not equal, right? If 6 electrons are lost, then 6 electrons should be gained. So the number of electrons lost or gained is not equal. Means the ions are not balanced. The charges are not balanced. Okay. So atoms are balanced. In the second step itself, all the atoms are balanced. Not all the atoms, chromium and sulfur are balanced. Except oxygen, everything is balanced. But the charges are not balanced. So what I have to do, I have to go for the fourth step. So balance the increase or decrease in the oxidation number by multiplying some suitable number. Okay, by multiplying by suitable number. So these are the oxidation numbers, right? So what you can do? You can multiply the chromium by 2 so that you will get 6. And if you want to make sulfur also 6, what you have to do? You have to multiply this plus 2 by 3. So 2 into 3 will be equal to 6. Okay, minus 6 and plus 6. The number of electrons lost and gained are now equal. Okay, so this is the suitable number which I have used to balance the charges. Okay, so 3. So since I have multiplied this by 3, I have to multiply the sulfur by 3 in both the sides. Okay, I have to multiply sulfur by 3 in both the sides. Then only the atom will get balanced. Okay, simply I cannot balance the charges alone. I have to balance the atom also in the side by side. Okay, now we have to balance the charges, right? Charges of all the elements. So in the question itself, they have given that the medium is acidic. So if the medium is acidic, then you have to use H plus. If the medium is basic, then you have to use OH minus. Okay, so charge balance should be done using the addition of H plus and OH minus. So this is the reaction. Since in the question they have mentioned that we have to do the reaction acidic medium, I am going to multiply this reaction by H plus. I'm going to multiply this reaction by H plus. Okay, why I have written 8H plus here? Why I have written 8H plus? Any idea? So here 1 into minus 2. 1 into minus 2 is minus 2. Here 3 into minus 2. 3 into minus 2 is minus 6. The total number of charge in the left hand side is minus 8. In the right hand side, 2 into plus 3 is plus 6. 3 into minus 2 is minus 6. So minus 6 and plus 6, it is equal to 0. So in the left hand side, I have minus 8 charge. In the right hand side, I have 0 charge. So what I have to do, I have to equalize the charge in both the sides, right? So that's why I am multiplying this with 8H plus. So 8 into plus 1 will be plus 8. So that minus 8 and plus 8 will get cancelled with each other to give the 0 charge. Charges are balanced. Charges are also balanced. Do you guys have any doubt till this step, fifth step? Any doubt till the fifth step? Students, any doubt till step number 5? Clear? Ajmala, Chandu, Devananda, Farnas, Nandini, Kartika, Pragati, just give me your answer. Do you have any doubt so far till this fifth step? Shall I go ahead with the sixth step?
Yes, ma'am.
Write the oxidation number. Okay. Balance the atom. Then balance the charge. Okay. If the medium is acidic, put H plus and balance the charge. If the medium is basic, put OH minus and balance the charge. Okay. Then in step number 6, add H2O to balance the hydrogen and oxygen. So far, till step number 5, you see, till step number 5, we did not balance the hydrogen and oxygen. We have just balanced only the chromium, sulfur, that's all. Hydrogen and oxygen is still to balance, right? So to balance that, we have to put H2O in the right hand side. We have to put H2O in the right hand side. I have put 4H2O because I have 8H plus, right? So I will have to use 4H2O. Then only 4 into 2 will be 8. Okay, so hydrogen is also balanced. Now, if you try to balance the oxygen, it will be balanced. So here I have 7 oxygen. Here 3 into 3, 9 oxygen in the left hand side. So totally it is 16. And here 3 into 4, 12. And 4 into 1 is 4. So here also we have 16. Oxygen is also balanced. Okay. So this is the final step. And at last you can verify. At last you can do the verification. How we can do the verification? Find out the atoms of each element. Check whether all the atoms are balanced. Then check if the total charges are balanced. Okay. So if both are getting balanced, then your final reaction is the answer for the given question. Okay. So we have 1 Cr2O7 2 minus, 3 SO3 2 minus, and 8 H plus in the reactant side as the coefficient. Okay. Mostly in the examination, they will ask you to find out these coefficients only. Okay. You can get the coefficient only if you balance the redox reaction. Got it? Any doubt for anyone from this? Do you guys have any doubt in balancing the reaction using oxidation number method? Shall I give you one equation as an example? Can you guys go home and do that as an example and come back in the next class? Shall I give? Okay. So this is the reaction. Balance this equation by oxidation method in basic medium. Yeah, very good, Pragati. So this is the question. Take down this question. You have to balance this by oxidation number method in basic medium. In which medium? In basic medium. Okay. So take this as a homework and try to find out the answer in the next class. Okay. So we have class tomorrow. Ask you the answer. You guys can say. Shall we go for the next one? Just give me some time. Shall we go for the next reaction? Yes or no? So all of you please wait for some time. Yeah. Can you all able to see the screen now? Oh my God. You did not note down the question, my dear. Okay, I will show the question at the last, okay? I will show the question at the last. I will show the question at the last. Is it okay? Wait, I will show. So it is MnO4 minus, just take down the question. MnO4 minus all of you please note down the question. It is MnO4 minus reacting with Br minus, MnO4 minus in aqueous medium, okay? Aqueous medium with the Br minus in aqueous state to give MnO2 in the solid state plus BrO3 minus in the aqueous state. So this is the question. MnO4 minus plus Br minus giving MnO2 and BrO3 minus. All right. So use oxidation number method to find out the product in basic medium. Okay, good. So now let's go with the second type of method, which is half reaction method. We'll use half reaction method and try to balance the equation. Okay. So this half reaction method is otherwise called as ion electron method. Half reaction method is otherwise called as ion electron method. So let's take one example. Fe2 plus reacting with Cr2O7 2- to give Fe3 plus and Cr3 plus. This is the example taken to understand the half reaction method. Okay. So here in step 1, what you have to do, separate the equation into half reactions. Separate the equation into half reaction. Half reaction means oxidation half reaction, reduction half reaction. So if you want to separate, you should know which element has oxidized and which has got reduced. Okay. So again, write the oxidation number. Now you can able to understand, right? Fe is going from +2 to +3. So it is the oxidation half reaction. Okay. And chromium is moving from +6 to +3. So it is gain of electron. So that is a reduction half reaction. Okay. So separate the reaction into two like this. Oxidation half reaction and reduction half reaction. If there is increase in oxidation number, it is oxidation half reaction. If there is decrease in the oxidation number, it is reduction half reaction. Okay. So after separating the equations like this, see here. After separating the equations like this, the second step that you have to follow is balance the atom other than oxygen and hydrogen in each half reaction individually. Now don't think about oxygen and hydrogen. Balance the other atoms. The other atoms are iron and chromium, right? So if you go for oxidation half reaction, the iron is already balanced. We have one iron in both the cases. So it is already balanced. But here in the reduction half reaction, we have 2 chromium in the left hand side and 1 chromium in the right hand side. So what I have to do? Multiply the product chromium by 3. No, sorry, 2. Multiply the product chromium by 2. Okay, now I have balanced all the atoms except oxygen and hydrogen. Okay, so now what you have to do, listen. So this is the balanced equation. So now in the third step, if the medium is acidic, for acidic medium, add H2O to balance oxygen atom and H plus to balance the hydrogen atom. The same thing which we have followed in the previous case. Okay, if the medium is acidic, you have to use H plus to balance the hydrogen atom and H2O to balance the oxygen atom. Okay, so I am going to put 7H2O here. I'm going to put 7H2O here. So why I have put 7H2O specifically? I have 7 oxygen. So I have put 7H2O. Okay, 7 oxygen will come. So now the hydrogen count is 14. 7 into 2 is 14. So put 14H plus in the reactant side. Put 14H plus in the reactant side. So now hydrogen and oxygen, both of them are got balanced. Okay, any doubt? Any doubt so far? Separate the equation into 2. Balance all the atoms except oxygen. Then to balance the oxygen and hydrogen, if the medium is acidic, add H plus and H2O. Okay, any doubt so far? Shall we go for the next step? Shall we go for the next step, students? All of you can able to understand till this, right? Shall we go for step number 4? Yeah. So now all the elements are balanced, but charges are not balanced. So to balance the charges, what you have to do is add electron to one side of the half reaction to balance. Okay, add electron. That's why this method is called as ion electron method. This is called as ion electron method. Okay, add electron to one side of the half reaction to balance the charges. So here in case of oxidation half reaction, Fe is moving from +2 to +3 with the removal of one electron. Right? With the removal of one electron. In the product side, in the reduction half reaction, if you see, if I calculate the charges, here I have 1 into -2. So it is -2. 14 into H plus 1. 14 into plus 1 is plus 14. So which is actually equal to plus 12 in the reactant side. And in the product side, 2 into plus 3 plus 6. 7 into 0, so 0. So the total number of charge in the product side is plus 6. So plus 12 in the reactant side and plus 6 in the product side. Charges are not balanced. Okay. So what I have to do? I have to add 6 electron in the reactant side. I have to add 6 electron in the reactant side. So I will get minus 6 into minus 1. 6 into minus 1, right? So it is minus 6 in the reactant side. So plus 12 minus 6 is equal to plus 6. So now the charges are also balanced in both the sides. Is it clear? Is it clear to all of you? Can you all able to understand? To balance the charges, I am adding 6 electrons. To balance the charges, I am adding 6 electrons in the reduction half reaction. Now, since I have added 6 electrons in the reduction half reaction, I have to have 6 electrons in the oxidation half reaction also, right? Only if only the 6 electrons are getting lost by iron, then those 6 electrons can be gained by chromium. 1 electron in one reaction and 6 electrons in another reaction is not possible. Okay, so I have multiplied this entire equation by the number 6. I have to multiply this entire equation by the number 6 so that I will get 6 Fe2 plus, giving 6 Fe3 plus and 6 electron. Okay, so now what you do? This is the final reaction. You can cancel the common terms. You can cancel the common terms. Who are the common term? Now add the two half reaction and cancel the electron on each side. The electrons will get cancelled. The other terms will not get cancelled. They are not common. So write the left hand side in one side. So this is the complete reaction of, and if 6 electrons are getting cancelled, this is the final. Okay, this is the balanced equation for this particular reaction. Okay, 6 Fe2 plus Cr2O7 2 minus with the H 14H plus is giving 6 Fe3 plus 2 Cr3 plus and 7H2. Okay. Which method is easy? Oxidation method or half reaction method? Oxidation number method or half reaction method? Which is easy? Finally, you can verify. You can verify whether all the atoms are balanced and all the charges are balanced. Okay. If you want to do the reaction with basic medium, follow all the steps of acidic medium, and for each H plus ion, add OH minus ion. Okay, add OH minus ion to both the sides. Clear? Oxidation number method is easy than half reaction. Okay, so you can use any one of these methods to find out the answer. Okay, you can use any one of this method to find out the answer. Okay. Clear? Students, am I audible? Am I audible?
Yes, ma'am.
So with this, we can wrap it up the today's session. So we will see the remaining things in the next class. Okay. So try to solve the question which I gave you as a homework. I have launched a poll. You guys can answer for all the 5 questions given in the poll and you can leave the class. Okay. Thank you. Take care. Bye.